lithium batteries, this 56-gram variant of Black Widow carried a black and white micro video camera, had excellent maneuverability, and could even hover or loiter for up to 22 minutes before returning to its base. Black Widow cannot be heard above ambient noise at 100 feet, reported scientists in the field. And unless you're specifically looking for it, you can't see it. Even birds were fooled. It looks more like a bird than an airplane, the scientists wrote. We have seen sparrows and seagulls flocking around the MAV several times. DARPA was enthusiastic. Remember, this was March 1999. The Black Widow MAV program has been quite successful in proving that a 6-inch aircraft is not only feasible, but that it can perform useful missions that were previously deemed impossible, read an after-action report. Then came the more important idea. A RAND analyst named Benjamin Lambeth concluded that mini-drones like the Black Widow had enormous potential, not just in intelligence, surveillance, and reconnaissance, but ultimately as a means of assassination. Mini-drones disguised as insects, Lambeth wrote, could one day be outfitted with micro-explosive bombs able to kill moving targets with just grams of explosive. DARPA expanded its micro-air vehicle program to include at least 3 research efforts or thrusts, each of which relies on the animal kingdom for inspiration and ideas. The results of these programs are called biosystems, biomimetics, and biohybrids. Biosystems involves the use of living, breathing insects or animals trained for military use. During the Vietnam War, German shepherds were trained to track Viet Cong fighters tagged with chemicals. During the Iraq War, scientists at Los Alamos National Laboratory in New Mexico trained bees to locate buried IEDs. These are 2 examples of biosystemic programs. Biomimetics research is a field closely related to bionics. In DARPA's biomimetics programs, scientists build mechanical systems to imitate creatures from the natural world. DARPA designed biomimetic drones, like the Black Widow MAV, include ones that appear to be hummingbirds, bats, beetles, and flies. If DARPA has dragonfly drones, they would fall under the rubric of biomimetics. Biomimetic drones have been used by the intelligence community since at least 1972, when the CIA built a prototype dragonfly drone it called Insectothopter. A miniature engine powered the drone's wings to move up and down. Insectothopter ran on a thimbleful of gas. Biohybrids tread on entirely new ground. DARPA's micro-air vehicle, or MAV programs, are built on decades of aviation technology, aerospace engineering, computer science, and nanotechnology, which is the science of making things small. Then, at the turn of the 21st century, a new field called nanobiology, or nanobiotechnology, came into being. Once relegated to the pages of science fiction, this burgeoning new discipline allows scientists to couple biological systems with machines. In 1999, DARPA awarded grants for biohybrid programs. The stated goal was to create cyborgs, part living creatures, part machines. DARPA's biohybrid programs remain shrouded in mystery. Biohybrid military applications are largely classified, but a few prototype programs have been unveiled. As nanobiotechnology advanced in the early years of the 21st century, tiny machines could realistically be wired into animals' brains, bodies, and wings. Starting in 2002, DARPA began periodically releasing incremental information into the public domain. That year, news of an early prototype emerged from a DARPA-funded laboratory at the State University of New York's Downstate Medical Center in Brooklyn, led by researcher Sanjeev Talwar. Scientists implanted electrodes in the medial forebrain bundle of a rat's brain, a region that senses reward. Wires the size of a human hair connected the electrodes to a microprocessor sewn onto the rat's back like a backpack. From a laptop 500 meters, a third of a mile away, Talwar and his team of scientists sent electronic pulses to the rat's medial forebrain. After using Pavlovian techniques to train the rat to respond to stimuli, DARPA scientists were able to control the rat, steering it left, right, and forward through a maze via brain stimulation. Animal rights activists cried foul. "The animal is no longer functioning as an animal," lamented Gary Franchone, an animal welfare expert at Rutgers University School of Law. But for the majority of Americans, lab rats are synonymous with scientific experimentation. The idea being it's okay to experiment on rats to control their brains in the spirit of progress. The rat was not generally perceived as a cyborg per se. It was just a lab rat hooked up to a machine. Over the next 5 years, DARPA's biohybrid programs advanced at an astonishing pace. Microprocessor technology was doubling in capacity every 18 months. By June 29, 2007, when Apple released its first-generation iPhone, Americans could now carry in their pockets more technology than NASA had when it sent astronauts to the moon. One of the first insect cyborgs was unveiled in 2009. Inside a DARPA-funded laboratory at the University of California, Berkeley, Professor Michael Harbiz and his colleagues coupled a green June beetle with a machine. The scientists implanted electrodes into the brain and wings of a 2-centimeter-long beetle and sewed a radio receiver onto its back. By remotely delivering electrical pulses to the beetle's brain, they were able to start and stop the beating of the beetle's wings, thereby steering and controlling the insect in flight. In 2014, DARPA scientists working at North Carolina State University again broke new ground, this time with the Manduca sexta moth, or Goliath worm, an insect with a metamorphic life cycle that lasts 40 days. During the late pupa stage, DARPA scientist Dr. Alper Boskurt and his team surgically inserted an electrode in the dorsal thorax of the moth, between its neck and abdomen. The tissue develops around the implanted electrodes and secures their attachment to the insect's body over the course of a few days, explains team member Alexander Verderber. The electrodes emerge as a part of the insect's body in the final adult stage as a moth. By taking advantage of the rebuilding of the insect's entire tissue system during metamorphic development, says Verderber, the scientists were able to create a steerable cyborg, part insect, part machine. One use of the biohybrid would be for use in applications such as search and rescue operations, Boskurt says. DARPA scientists working on such cyborg programs invariably describe the programs as designed to help society. Certainly, subjects like free will, ethics, and the consequences of manufacturing cyborgs are worthy of and ripe for discussion. Another question: what are DARPA's plans for augmenting humans with machines?